Connectivity can be considered across multiple spatial and temporal scales. In this video, we will discuss the different scales at which connectivity can be considered and how they work together to inform conservation planning. We can look at connectivity at a variety of spatial scales, all the way from trying to identify corridors across entire continents to finding paths through a specific subdivision. These maps show several connectivity conservation planning exercises at a variety of scales. In the 1990s, the Wildlands Network captured the imagination of the conservation world by producing their Continental Conservation Plan, a series of great wildways designed to preserve biodiversity across North America. The vision was to restore connectivity across the continent to the point where black bear populations in Florida, California, Appalachia, and Alaska could all be connected. This bold vision was then picked up by conservation planners across the continent who developed more regional level plans for how the continental vision could be realized. A portion of the Western Corridor has been realized by the Yellowstone to Yukon initiative, which we will hear about in a later video. Here, the second map shows the plan for the Eastern Wildway, which was designed to connect the Acadian forests of the Canadian Maritimes to the subtropical Florida Everglades. The plan consists of a series of habitat cores, large natural areas, mainly national parks and other protected areas, shown here in green, and the linkages between them shown in yellow, which together form a network to guide conservation across the region. The map you see here is a product of over a decade of collaboration between state, provincial, and national governments, NGOs, and academic researchers, including Dalhousie's Karen Baisley. Within the Eastern region, the governments of the Canadian Maritime provinces and New England states have recently made commitments to maintaining and restoring ecological connectivity across the region. The third map here is part of Nova Scotia's contribution to these commitments. We map the connectivity of the province's natural ecosystems, paying special attention to those areas least impacted by roads, those areas that would bolster connectivity between the province's protected areas, and those areas that would help restore connectivity to New Brunswick and by extension the rest of the continent. The final map here is an example of fine-scale connectivity planning. The goal was to look at connections between Sandy Lake, the Ingraham River, Blue Mountain Birch Cove Lakes wilderness area, and the Herring Cove backlands in the Halifax area. What we did was gather representatives from a number of different local conservation organizations in order to look at where remaining connections of natural ecosystems still exist in the region and where restoration efforts would be the most beneficial. We identified specific properties that, if protected, could have a major impact on biodiversity conservation in and around Halifax. We got as detailed as looking for possible connections between and across subdivisions and identified potential areas where wildlife crossing structures, which we will hear more about later, could be built to increase connectivity across roads. In addition to thinking about connectivity on multiple spatial scales, we also need to consider multiple temporal scales. Whether it be the links between food, water, and shelter sources, the routes of seasonal or once-in-a-lifetime migrations, or multi-generational movements like those in response to climate change, considering connectivity is important. The maps shown here depict different patterns of movements at various time scales. We know that animals need to be able to move around their landscape in order to meet their daily needs. They need to be able to find food, water, mates, and shelter. The map shown here on the far right tracks baboon movements over a few days, with each color representing a different day. These types of tracking studies help us to better understand where and when animals are using different parts of the landscape, and it gives us a sense of what connections are important at the very fine scale and where there are potential barriers on the landscape. Some species undertake long seasonal migrations, sometimes across entire continents. Here we see the tracking data for tundra swans as they make their annual migration between their breeding grounds in Alaska and their overwintering quarters in the southern United States. Using this type of data, we can start to see the broad patterns of movement that these birds use to access key habitat areas. Research like this, tracking a number of different bird species, has identified a number of key corridors across the continent that are used by huge numbers of birds every year called flyways. Other species may undertake a key migratory journey just once in their lifetime. This is the case with some fish which live out most of their lives in the marine environment, but return to the freshwater to spawn. An example of this is the sockeye salmon, and their migrations to their spawning grounds in the Fraser River system are shown here. Some species complete their long migrations over multiple generations. For example, the northward migration of the monarch butterfly from Mexico back up to their breeding grounds in the northern United States and Canada takes 4 generations to complete. Another type of migration that will occur over multiple generations are those in response to climate change. Climate change will mean that the suitable areas for a particular species will shift, in general moving north or upslope. Because of the tight relationships between climate and the ability for a species to persist, species will need to move with their preferred climate as climate change progresses. It is expected that many of these climatic shifts will occur faster than many species can migrate in a single generation, meaning that it will take multiple generations for a species to adjust to climate change-related range shifts. Here we see a map from the Nature Conservancy's Migrations in Motion project, which modeled the potential habitats for almost 3,000 species using climate change projections and the climatic needs of each species. They then used flow models based on electric circuit theory to plot the potential range shift movements needed for each species, connecting their current habitats with their projected locations under climate change. In doing so, they identified some key movement corridors that are going to be essential for supporting species through a changing climate across North and South America. The examples of connectivity conservation planning across multiple scales that we just overviewed, coupled with 3 decades of research and on-the-ground action, have taught us a number of key lessons. The first is that collaboration across jurisdictions is essential. A connected network of natural ecosystems across North America requires collaboration between multiple countries and indigenous nations, dozens of states and provinces, and hundreds of counties and municipalities. While it is useful for each jurisdiction to have their own conservation plan that incorporates connectivity, the most impactful conservation outcomes have occurred where jurisdictions coordinate their efforts, where lower levels of government work to fill in the gaps of higher level plans. Having a broader scale plan to point to can help guide resource allocation and identify priority locations for conservation at the finer, more local scale where land use decisions are typically made. Building on the need for collaboration is the fact that there is no need to reinvent the wheel. While each jurisdiction and landscape is unique and presents its own challenges, there are a lot of lessons that can be learned by looking to similar jurisdictions that have already gone through the process. Basically, there are a lot of good ideas out there, you just need to look for them. For example, the Eastern Wildways Plan that we looked at earlier learned a lot from the Yellowstone to Yukon initiative, which had started a decade earlier. And here in Nova Scotia, we've been looking to similar work done in New Brunswick and throughout New England. Finally, it helps to have both scientists and political decision makers at the same table from the get-go. This allows potential conflicts in land use planning, conflicts arising between biodiversity conservation, energy, food production, and other natural resources like timber, to be identified as early as possible. This allows for conflicts to be dealt with early on, and by having decision makers a part of the process from the get-go, it increases the chances that the plan developed will actually be implemented.